Hi Calculus ABBC, welcome to a brand new video. I'm here to help you step by step on how to pass Sig Test 18 real quick and easy. Subscribe and make sure to turn on post notifications. Number 18, fundamental theorem on a graph. The graph below shows the function v of t, which is composed of line segments and semicircles. Bada bing bada boom, and here's the velocity graph we are given for the problem. For this, they're asking us to find the area from bounds 2 to any sort of value on the graph. The first part is trying to find a of -5, or the area from bounds 2 to 5. Although, this can't happen, since the upper bound must be greater than the lower bound. Remember, in order to fix that, we can make the integral negative to flip the bounds over. Now the bounds are -5 to 2. Next step is to look at the graph and calculate the area under the curve from -5 to 2. Your value should equate to this, with having shapes equal to -1, 5.5, half, -half, and 2 minus pi over 2. Also, remember that areas underneath the x-axis are shown as negative, not positive values. If we go ahead and solve this with algebra, you should end up with this. Don't forget the negative sign in front of the integral. In the end, we should have -6.5 plus pi over 2 as our answer. Now that you have the hang of this, pause and try the rest of these problems. Find the area from bounds 2 to 2 and 2 to 4. The answer is given at the end of the video. Almost forgot, but you may come across a problem like this. In a simpler way, it's asking you what the y value is on the velocity graph when x is equal to -3. As you can see, y is 2 when x is -3. Easy, right? Now we're on to part B. Let v of t represent the velocity of a particle moving up and down, up and down, up and down, up and down, a pole, in centimeters per second, and let the particle be 10 units underground at t equals 2 seconds. Set up an integral expression and compute. Our job here is to make an integral expression for the displacement and the total distance of the particle on domain 2 to 4. Let's bring back our graph from before. Bam bam. In order to do this, you must fully understand the difference between displacement and total distance. Displacement is a vector whose length is the shortest distance from the initial to the final position point. However, total distance is not the shortest distance from point A to B, but the actual distance of the full-on route. You can also see that total distance is the absolute value of displacement. The integral expression for the displacement would be v of t dt from bounds 2 to 4. If the areas of the triangles below are half and -half, the answer to displacement would be 0. Also, don't forget to mention your units here as centimeters. For total distance, as said before, it would be the absolute value of v of t dt from bounds 2 to 4. That means everything below the x-axis is flipped above it and becomes positive. Since both areas add up to 1, the total distance from 2 to 4 is 1 centimeter. Finally, we are asked to find the actual position of the particle at t equals 4.
Yay, I'm back!
Remember, in the problem it's a given that the particle is 10 units underground, so start by adding -10 to the displacement, not total distance from earlier. Remember that if a particle goes up or down, add or subtract respectively. If it goes left or right, don't do anything, as it doesn't affect the actual position. Calculate for the position, and you'll have the particle's position at -10 centimeters. Well, thank you for watching this video. Good luck on your further Sig tests. Peace!